tell you heat for sure 15 minutes or 20 minutes. Tell you. 20 or 30 minutes. 20 to 30 minutes. Okay. You're going to heat for 20 to 30 minutes. If you don't long enough, you are not converting copper hydroxide to copper oxide. And that's why you're going to lose the copper. So that's why I say don't try to rush. Try to be skimpy on the time. You want to make sure entire copper hydroxide convert into a copper oxide. So after you heat it for 30 minutes, well, it's about done. Okay, it becomes. So that is a decomposition reaction. Then you're going to add 15 ml of concentrate solubilic acid. Okay. Solubilic acid, nitric acid, solubilic acid. Same way. If you spill solubilic acid, here is a bicarbonate for you to neutralize it. Hit on your shirt, go burn a hole. Okay. Yeah.
If you have counter spills, do you want us to pour the sodium bicarbonate before?
Yeah. Just
on the counter.
Yeah.
Okay.
But you're gonna pour acid. Make sure to pour in there, inside the hood. Okay. You're gonna add 50 ml stiff monolytic solubilic acid. Okay. Now the copper oxide black solubilic acid. What kind of reaction is this?
Acid base.
Huh?
Acid base.
Acid and base, that's right. And then also acid and base, also double replacement. Yeah.
Question, why is it considered an acid?
Well, because this is oxide involved. That's why they classify as acid and base. But my classification is dissolution. Dissolution, that's dissolving copper oxide. So there's another name for it. I didn't put. It's vague, okay? For this, it's vague in terms of acid-base reaction, but the solution is dissolving.
Okay. So is that the acid-base dissolution reaction? That's going to be the same as up in that first step as well, correct?
No,
No.
this is a solubilic acid. This is solubilic H2SO4. First step is HNO3.
We're thinking maybe it was the second one. I had the
There's
second.
no second one.
The second one you're still talking about being an acid base as well.
There's no solubilic acid in the second step or third step. Only the fourth step. Fourth step where solubilic acid appear.
No, I get that, but you were talking about the different, I think it was in the second reaction, the different types of, because I have written down double displacement, precipitate, and then you're talking about a third one.
The third one is
No, you're, for the second reaction, I'm trying to understand all the reactions.
that's an acid and base.
For the second one?
Yeah.
Is that considered-
Acid and base also.
So that's just kind of the same type of reaction as
Yeah,
that
another
one?
one.
Okay,
Yeah.
that's what my question was.
Okay. So. Okay, you add it, and then black solid after you decant it. Okay. You add solubilic acid, and then it's turned dark blue solution again. So this is the full solution aqueous. Okay. So okay.
This one's under the hood also?
This one? No, not yet. This one, your heating, this will be, if you close to the hood, you are doing conversion. You're going to position this step close to the hood in front of you. That must be under the hood, first step. The second step, well, you're going to hold. So this heating will be, so how do you check? I say, oh, copper oxide, acid, what type of reaction? Is it possible? Is it possible redox reaction? Huh? Right? You
No,
can, yeah. Right?
because the copper doesn't.
Copper hasn't changed the oxidation number. Hydrogen hasn't changed the oxidation number. SO4, the whole unit hasn't changed the number. So that's not the redox reaction. So that is acid base or the solution. Okay, now you have a copper sulfate. Okay, the blue. Now, the final step, this is what final step, you're gonna measure approximately 2 grams of zinc. You have a blue solution. You can have 2 grams of zinc in there. Oh my gosh. You add in there, and you see brown copper drops out. Okay, as soon as you add a zinc and then the brown copper stuff, drops out, and the solution, blue solution becomes colorless. Okay. What is this reaction?
Redox.
Okay, why?
Zinc gets oxidized.
Huh?
Zinc gets oxidized.
Okay.
And the copper gets reduced.
Good. Okay, so that step is redox reaction. So now copper settle out. You measure approximately 2 grams of zinc. But how do you know that 2 grams will be consumed entirely by this reaction? Huh? How? Okay, you added 2 grams, but do you know exactly 2 grams or 2.1 grams or 1.9? You don't know. You have excess. 2 grams is excess zinc. Okay, it's excess. Too much for the reaction. So how do you remove the zinc?